In this interactivity, we will introduce kinetic energy while going over the following: its definition, its formula, and application. Kinetic energy is the energy associated with a moving object. The faster it's moving, the greater is its kinetic energy. When an object is static, however, meaning that it's not moving at all, its kinetic energy is zero. Now let's check the example of a weightlifter. As the weights move upwards, they have a kinetic energy associated with their motion. Their kinetic energy is symbolized by EK or KE. At the top, the weights are stationary. Then their kinetic energy is zero. However, their potential energy PE has increased. So again, a moving object has kinetic energy and its amount depends on two values: the mass m of the object and its velocity v. Then the formula to calculate kinetic energy is given by EK equals to half or 0.5 multiplied by m multiplied by v to the power of 2, half mv squared, where m is the mass and v is the velocity of the object. So let's say in this example that the weights have a mass of 50 kilograms and are moving at 0.4 meters per second. What is then their kinetic energy? So have a moment and try calculating it by yourself. Well, using the formula of the kinetic energy that we've just presented, which is EK equals to half mv squared, and knowing that the mass is 50 kilograms and the velocity is equal to 0.4 meters per second, then evaluating these values in the equation of kinetic energy, we will end up with half multiplied by 50 kilograms multiplied by 0.4 meters per second to the power of 2, which is equal to 4 joules, as the joule is the metric unit of kinetic energy and energy in general.